Welcome to the introductory session on gaseous state. In this session, we will be seeing states of matter, gas laws like Boyle's law, Charles' law and Avogadro's law. So, these are the topics we will be dealing in this session, that is we will be briefly discussing what do you mean by states of matter. Then we will be seeing the gas laws, namely Boyle's law, Charles' law and Avogadro's law. Now, let us move on to the topic. Matter, as you all know, it is anything that has got mass and which occupies a space. Anything which has got mass and occupies space, we call that to be a matter, and this matter is classified as solid, liquid or gas depending upon the external conditions like temperature and pressure. Now, here there is a picture of just depicting the solid state, liquid state and gaseous state. Here you can see that in the solid state it has got a definite shape. Though I am keeping the solid in a very big cube, it has got a definite bounding surface and therefore, it retains its shape whether it is kept in a bigger vessel or not. So, that is solid. Now, when we come to liquid, again that also has got a definite bounding surface and therefore, though the cube is a bigger one, still the liquid occupies only its defined space. Now, when we come to gas, the case is different. If you keep this in a small cube, the gas will be compressed to a small volume. Now, since this is all the three cubes are of the same size and you can see the gas molecules, they are occupying the whole cube. That is because it does not have a definite bounding surface. So, there is a difference between gas, liquid and solid, and here you can see in solid it is compactly packed, liquid it is slightly extended and in gas the molecules or the particles are very free to move about. That is, you have the intermolecular spaces, that is space between the particles, it is very high in the case of a gas. Now, let us see gas laws, that is to explain the behavior of gases under certain conditions like temperature and pressure. There have been certain laws predicted which is obtained from a theory known as kinetic theory, which gives a model picture for the gaseous state. So, that kinetic theory explains how a gas will be. Okay. And based on that, we have certain laws known as gas laws to show the behavior of gases with changes in temperature, pressure, etc. And that will be a quantitative relations, and these are known as gas laws. So, first we will go for the gas laws. They describes the behavior of gases under constant temperature, pressure, volume, amount of gas, etc. And these laws are known as gas laws, and we will see the first one. First law we will be seeing Boyle's law, and in Boyle's law you can see that I have highlighted the points, that is at constant temperature. It is very important, the temperature is constant. The volume of a given mass of a gas, that is also important, volume, and it is given mass means the mass is fixed, and mass fixed means you can also say it in other words as number of moles. So, number of moles are fixed. So, the volume of a gas of a given mass is inversely proportional to its pressure. That is, volume is inversely proportional to pressure means if volume is increasing, pressure should be decreasing, and if volume is decreasing, the pressure naturally should be increasing. That is the meaning of inverse proportional. Now, here it is represented mathematically as V proportional to 1 by P, where V represents the volume and the capital P stands for pressure. Now, here V is proportional to P, and do not forget that these two are fixed, that is temperature is fixed, mass is fixed, or the number of moles, I am denoting it as small n. In other words, I can say that n is also fixed. Temperature and mass fixed, volume will be inversely proportional to the pressure. See, V is inversely proportional to pressure, that is temperature and mass are constant. I can put it as V equals equality by introducing a constant k, which is known as proportionality constant, into 1 by P. Okay. Now, what I am going to take is, I am going to take P over the other side, that is P V is equal to K. K means that is a constant. For a gas, actually the temperature, pressure, volume, mass, all these are variables. Now, what I am going to do is, I am going to fix both the temperature and mass. Mass, or in short I will put it as number of moles n. If these two are going to be fixed, then the variables are only P and V. Now, what I am going to do is, when a gas is maintained at pressure P 1, let its volume be V 1. When I vary the pressure to P 2, let the volume be equal to V 2, and if it is pressure is P 3, the corresponding volume be V 3. If P into V is constant under these conditions, temperature and mass, now I can put this according to Boyle's law as P 1 V 1 will be equal to P 2 V 2, which is equal to P 3 V 3, and if you have more, it will be gone like that. The only condition is temperature and the mass of the gas should not be changed. You take a fixed mass of a gas, keep the temperature constant, you can vary the pressure and measure the volume, and these two products will be constant. That is what is meant by Boyle's law. Now, here we have a plot of pressure versus volume plots here shown, and here you can see that when pressure and volume are plotted at temperatures T 1, T 2 and T 3, where T 1 is lower than T 2, which is in turn lower than T 3. T 3 is the highest temperature, and you can say that it is inversely proportional, and you can see that as pressure increases, what is happening to the volume? Volume is decreasing. See, here we have a very high pressure. Okay. These are the corresponding volumes in the each case. Okay. Now, when we have a lower pressure, so this is a lower pressure, and you see the corresponding volumes here, they are all different. See, this is the corresponding volume coming over here. It is greater because the pressure is lowered, volume increases. So, they are inversely proportional. Now, here there is again a plot of pressure versus 1 by V, inverse of volume, and in this case you can see that it is keeping on, it is 1 by V. So, we have a straight lines, you can see the straight lines going on because it is P is proportional to 1 by V. Okay. Then next is, I am going to take the product of PV, pressure into volume, and that will be constant, and therefore, you get a straight line. See, for all temperatures, this K1, K2, K3 represents the temperatures in Kelvin, and you can see that as though the temperature is increasing, still the product of pressure into volume is a constant when it is plotted against pressure. See, we are getting a straight line parallel to. So, this again proves that PV is a constant or Boyle's law. Now, let us move on to a problem based on Boyle's law. Here, we have taken a sample of a gas at 25 degrees Celsius was compressed from 200 ml to 0.122 liters. Its new pressure is 750 torr, and what was its original pressure? So, here the temperature is fixed, it is 25 degrees Celsius. Now, it is compressed from a volume V1. So, the starting volume V1 is equal to 200 ml. Okay. It is compressed from 200 ml to, see, just note the units, in this it is ml, in the other case it is in the liters. You can do either convert the liters into ml or you can convert the ml into liter. You should keep both the volumes in the same unit. Now, what I am going to do is, I am going to convert it into ml just because this is a fraction. So, that will be 122 ml. Okay. Now, pressure, it is given in 750 torr, need not bother about that because the answer will also be in the same unit. Okay, since it is a ratio. Now, we are going to take the expression P1 V1 is equal to P2 V2. So, this pressure, its new pressure is 750 torr. So, the previous pressure we do not know what it is, and that is what we have to find out. And here this pressure will be taken as P2, and what we have to find out is P1. So, applying these values, that is P1 will be equal to P2 V2 by V1. P2 is 750, it is taken in torr, into V2, V2 is 122 ml divided by 200 ml. Now, you can just find out this ml and ml, both units get cancelled, and you will be getting the answer in torr, and when calculated the answer will be 457.5 torr. Hope it is clear. So, that is about Boyle's law. Next, we are moving to the next gas law known as Charles' law. Here again, at constant pressure, there it was constant temperature, here it is constant pressure. Again, it is again a fixed mass of a gas. The volume of a given mass of a gas is directly proportional to its absolute temperature. Here pressure is constant and N is constant. Okay. When we consider the volume, it is directly proportional to the absolute temperature. What does it mean? If temperature is increased, naturally the volume of the gas will increase. If you lower the temperature, the volume of the gas will also get lowered. So, there is a direct proportional. In the other case, it was inverse proportional, and in this case, it is a direct proportional. And do not forget that pressure and mass or number of moles both are fixed. Now, again this is a proportionality constant, we will introduce, that is equal to, again I am putting it as K into T, or I can say that V by T is equal to K, which is a constant. Now, again just like what we have done in the case of Boyle's law, here V by T is a constant, which means that if I take the pressure constant and mass is fixed, if let at a temperature T1, let the volume be V1. Okay. If temperature is changed to T2, let the volume corresponding be V2. Another temperature T3, let the volume be V3. Now, if this is the condition for fixed pressure and fixed mass, I can put it as V1 by T1 will be equal to V2 by T2, which is equal to V3 by T3, and so on, and all these will be constant. So, that is what is meant by Charles' law. Now, you can see the plot here, you can see that volume is plotted against temperature, and you can see that it is, they are all straight lines, okay. and mind that when pressure is high, the value of volume should come low. So, this is a P4, P3, P2 and P1. This is a P1 for which we will having higher volumes because it is a lower pressure. See, P1 less than P2, less than P3, less than P4. So, the lowest pressure is P1 and here correspondingly you will have higher volumes. At P4 being the pressure higher, you have lower volume values. Okay. So, they are all straight lines. This is a proof to show that the Charles law is true. Next, let us go for a problem. A sample of helium gas has a volume 520 centimeter cube at a temperature 100 degree Celsius. Calculate the temperature at which the volume of the gas will be 250 centimeter cube. Assume pressure to be constant. So, a sample of helium gas we have taken. So, once the sample is taken, that means that its mass is fixed. We are not going to add gas into it or remove it from it. So, the mass is fixed. Now, this has got a volume of 520 centimeter cube and the temperature is 100 degree Celsius. So, I am going to put this as V1, volume is equal to 520 centimeter cube. What is the temperature? The corresponding temperature T1 is equal to 100 degrees Celsius, and you have to remember that in no calculations or in anything in chemistry, we will be using temperature in Kelvin scale. So, we have to convert this temperature to Kelvin scale. For that, I have to add, or I will just put it the other way, which will be equal to 273 plus 100, that makes 373 Kelvin. So, this is an important point. Should note that temperature should be always converted into Kelvin scale for any calculation. Now, here we have the temperature as 373. Now, T2 is not given, but V2 is given. V2 is equal to 250 centimeter cube. Here please note that the unit of volume both are in centimeter cube. So, I am not going to alter or convert it into any other liters or milliliters or anything, because both the volumes are in the same unit. And we are supposed to find out the temperature at which the volume has been reduced from 520 centimeter cube to 250 centimeter cube. Again, applying Charles law, we know that V1 by T1 is equal to V2 by T2, and we want to find out T2. So, I am going to take T2 to this side and taking these two terms to this side, both the terms, both V as well as T together to this side. So, the expression will be like T2 on this side, V2 is already here. Okay. Now, when I take these two to the other side, the denominator when it comes over here becomes the numerator. So, that will be T1 and the numerator becomes the denominator, that is it is getting inverted. Okay. And substituting the values, V2 is equal to 250 into T1, the temperature is 373 whole divided by V1, that is 520, and this is centimeter cube, this is also centimeter cube and this is Kelvin. These two will get cancelled and the unit of this will be Kelvin, and the answer is 179.33 Kelvin. So, that is the answer, just solve for it and you will get it. Next is Avogadro's law. Here you are going to keep the temperature constant, pressure constant. So, next variants are volume and number of moles, or you can say the mass. Now, here what we apply is number of moles, and therefore, at constant temperature and pressure, the volume of a gas is directly proportional to the number of moles of the gas. Now, before going in detail to the number of moles, let us see how we will find out the number of moles. Now, if we have a gas of mass W. Now, its molecular mass, if that is equal to capital M, okay, then number of moles, which I am denoting as small n, will be equal to mass divided by molecular mass. Okay. Now, this is how we are going to get number of moles. We know that for any given substance, the molecular mass is fixed. If I say it is oxygen gas, its molecular mass is fixed. If I say it is a nitrogen gas, its molecular mass is fixed, and therefore, mass is the only thing. Let I am taking, suppose I am taking 2 grams of mass, I can take 10 grams of a mass. So, mass can vary, but molecular mass is a constant thing, and therefore, number of moles actually that depends upon what it is the mass taken. Okay. So, here instead of saying mass, we are going to use the word number of moles. At constant temperature and pressure, the volume of a gas is directly proportional to number of moles. So, if you are having, if the temperature and pressure is constant and you have taken different gases, okay, once if I take the volume, if I measure the volume, if the volume is higher, it means that is having number of moles greater. That is, suppose I am going to take hydrogen gas, suppose hydrogen gas, okay, and if this hydrogen gas has got a volume of just for clarification sake 50 ml, okay, here temperature and pressure constant. So, I have taken some amount of hydrogen gas, and if its volume is 50 ml, okay. Now, I am taking another sample of hydrogen gas, and if it occupies a volume of 100 ml, you can be sure that like how many moles are there in 50 ml and how many moles are there in 100, because that will be twice the number that in this case. Here it is only occupying 50 ml means the number of moles, let it be x. Okay. Now, if that hydrogen gas is occupying a volume of 100 ml means sure it will be having double the number of moles as in the previous case. Okay. So, here we say that when temperature and pressure is constant, V is directly proportional to number of moles. Hope I have made it clear. Now, from this we have another assumption or a consequence from this, that if I am taking equal volumes of all gases and then the same conditions of temperature and pressure, that is, if the temperature and pressure is same and if the gases are of equal volume, okay, they will contain equal number of molecules, because number of moles means, I will just clarify that 1 mole means Avogadro number of molecules. It is denoted as N naught, or I can put the value as 6.022 into 10 to the power 23. Okay. So, equal volumes, I am taking equal volumes of many different gases, and if they are having same volume, they are same volume at the same temperature and pressure, the number of moles contained in them will be same. That is, if I am taking 1 liter, suppose I am taking hydrogen gas, I am taking oxygen gas, I am taking nitrogen gas. Okay. The temperature and pressure fixed. volume is fixed. That means number of moles of hydrogen in that case will be equal to number of moles of oxygen, and that in turn will be equal to number of moles of nitrogen. So, that is the consequence, one of the consequence from Avogadro's law. Equal volumes of all gases at the same temperature and pressure conditions will have equal number of molecules. Okay. The volume occupied by, now another consequences, if this is the case, the volume occupied by 1 mole of any gas. Now, this volume is known as a molar volume, that is a volume occupied by 1 mole. Okay. So, 1 mole of any gas, if I take under the same conditions of temperature and pressure, okay, that is volume occupied by 1 mole of a gas, the temperature and pressure is same, will be having the same number of moles, that is, and that is volume occupied by 1 mole of any gas is same, that is, if I take 1 mole of hydrogen, I am taking 1 mole of nitrogen, whatever be any gases you can take, provided they are 1 mole. If I take 1 mole and they are all maintained at the constant temperature and pressure, then if this hydrogen has got N1 moles, suppose let it be N1 moles, then nitrogen will also be having N1 moles. That is another consequence, and from that we get one deduction, like the molar volume of any ideal gas at STP, that is standard conditions of temperature and pressure, and they are 273 Kelvin and 1 atmosphere pressure. Actually, it is taken as 1 bar, but 1 bar and 1 atmosphere makes no much difference, and therefore, you can take it as 1 atmosphere itself. It is equal to 22.414 liter. See, molar volume means it is the volume of 1 mole. Okay. Temperature and pressure fixed, that is 273 Kelvin and 1 atmosphere pressure, will have a volume of 22.414 liter. So, this has got many consequences, we can make many calculations out of that. For example, if I am taking 1 mole of nitrogen, okay, at STP, okay, it will occupy, the volume occupied will be 22.414 liter. I can change the gas, let it be 1 mole of argon at STP, again the volume occupied will be 22.414. I am taking 1 mole of hydrogen at STP, again the volume occupied by 1 mole, it will be 22.414. It is a very beautiful consequence from Avogadro's law, and this 1 mole means mass by molecular mass. So, that is you will have to be conscious, it is 1 mole, okay, it is not molecule, and this 1 mole means it contains Avogadro number of molecules, N0 of molecules. Okay. One more clarification, like when I say number of molecules, it can be 2 types, like if I am taking, that is why I have taken different examples. So, if I take hydrogen, okay, 1 mole of molecules will be weighing 2 gram. Okay. If I am taking 1 mole of atoms, its mass is 1 gram. So, you should not confuse it with that 1 mole of, if I have taken H2, see it is hydrogen, it is a hydrogen gas. So, the mass is 2 gram. Okay. So, this will occupy a volume of 22.414 liter. Okay. It is not hydrogen atoms. So, do not confuse it with that. Okay. So, hydrogen molecule, that is 2 gram. If I am taking 2 gram of hydrogen, it will occupy at STP 22.414 liters. In the case of nitrogen, it is 14 and 14, 28. If I take 28 gram of nitrogen at STP, it will have a volume of 22.414. Do not confuse that with the atomic masses. Now, to conclude, we have been saying in this chapter, in this session, we have been seeing states of matter, that is, we know that we consider solid, liquid and gas. Depending upon the temperature and pressure conditions, the matter can exist as solid, liquid and gas. Of course, there is another state considered, but we do not have it here, that is a plasma stage, that is at a very high temperature. Normally, we have only solid, liquid and gas stages. Now, we have gas laws. Gas laws, they are formulated from a theory which we will be seeing in detail later, that is from kinetic theory. And from kinetic theory, we have to take some quantitative relations between temperature, pressure, mass, volume, etc. And for that, we have got certain laws known as gas laws. First one is the Boyle's law. In Boyle's law, we have found that at constant temperature and mass, volume is inversely proportional to pressure. Now, we have seen Charles' law. At constant pressure and mass, volume is directly proportional to temperature. Here it is a direct proportional, the other case it was inverse proportional. Hope the point is clear. Here inverse proportional means when volume increases, pressure should decrease. Here in this case it is a direct proportional, means if volume increases, temperature also it has to increase, or it is the reverse case, that is when temperature increases, volume naturally increases. Next is Avogadro's law. At constant temperature and pressure, volume is directly proportional to number of moles, that is, if you have a higher volume, number of moles also will be greater. Now, from that we get a consequence of Avogadro's law, or we can say it is an application of Avogadro's law, that is the molar volume of an ideal gas at STP is equal to 22.414 liters. And here it is mentioned ideal gas, which we will be seeing in detail what is an ideal gas. So, if it is a very perfect one, all these laws are applicable. Thank you.